So, good afternoon, everyone, and thank you so much for joining us today on this second webinar from our pollution prevention series. So, today our focus is going to be on automotive, aerospace, and the metal manufacturing industry. My name is Chris Brazil. I'm a pollution prevention specialist at Kansas State University's Pollution Prevention Institute.
And I'm Jacob Larson, also a pollution prevention specialist here at K-State PPI.
So for our agenda today, we're going to start with talking a little bit about our program and what are our current initiatives. We're going to go over some different types of pollution prevention strategies, and Jacob will be making that link to their compliance benefits. Potential compliance benefits. And then at the end, we're going to leave some time for any Q&A. So at the time, you can keep sending us some questions in the chat, but at the end, you can also unmute yourself if you want to ask us a question directly. So to start about our program, so we were founded in 1989, and we are housed in the Engineering Extension Department, which is part of the College of Engineering here at K-State. Our program is 100% grant funded. Our current funding comes from the EPA and the KDHE. And it's always important, we always like to mention that although we are funded by these agencies, we are a non-regulatory program, so we don't do any sort of compliance enforcement as part of our institute.
But one of the things that we do through PPI is we host the state's Small Business Environmental Assistance Program. It's something that each state has one of these. Each state has an SBEP. In fact, there is a national Small Business Environmental Assistance Program that you can look out to find contacts for your state's SBEP. But the SBEPs were created in 1990s Clean Air Act as a way to help small businesses understand what their compliance requirements are for the Clean Air Act. What happens here at Kansas is we've actually expanded beyond just providing assistance on air, but we also provide some assistance to businesses on RCRA hazardous waste topics, stormwater permitting, and we do try and connect pollution prevention to all these different compliance topics as well, because pollution prevention, as we'll discuss later, can in fact help with reducing some of the compliance requirements under some of the different regulations that folks are governed under. We do focus, as the name implies, on small businesses, and what we define that is as businesses that employ 100 employees or less. That does include businesses that have parent companies, so all of the employees are accounted for or included. So we try and dedicate that assistance to small businesses, providing that free confidential assistance, education, going on site to facilities, going through walkthroughs, hotlines, all that good stuff. But we do provide some assistance as well to larger businesses if they have questions. We can give some good basic answers and try and help out and educate folks on environmental compliance.
And under our institute, we also house our pollution prevention program, in which, in this case, we can provide technical assistance to any size industry. One of our biggest programs would be our summer internship program, in which we pair Kansas students with Kansas companies to work on sustainability projects. We had 10 interns in the past summer working with a variety of different types of industries in Kansas. And we also do a lot of work regarding spreading P2 awareness in the form of workshops, seminars, or creating educational materials. So I will briefly talk about some of those during this presentation. And right now in our program, we were recently awarded 2 new P2 grants. So we are going to be continuing some of the current work that we are doing, but we're going to be also expanding along with some of the other grants that we have in-house. So we will continue to run our internship program. We will kickstart a new green brewery initiative in 2025, focusing on a certification and also providing technical assistance for this industry sector. And also working on environmental justice community events. We've been doing that for the past couple of years, and we're going to expand this work, connecting local communities, industry, and resources so we can all work together towards a more sustainable Kansas. And we have applications open if you are interested in becoming a host company in 2025 and hosting one of our interns. We do have some match opportunities available, including for industries in the sectors covered in this presentation. So if you're interested, I'm going to talk a little bit more about this at the end, but we can check if you qualify for 50% cost share for hosting an intern in the program. And we always like to start just clarifying a little bit, because pollution prevention can have different meanings depending on the source you're looking at. So for us, we use EPA's definition of pollution prevention, or P2. So EPA put together this waste management hierarchy that shows the most preferable way of managing waste and the least preferable way. So our program focuses on that top option over there, so reducing pollution at the source, so before we create or have to dispose of it or treat it. So reusing is definitely a type of project that we worked within our program, as well as it reduces normally the amount of source input that we need when we can reutilize some materials. And recycling, we do cover if it happens within the facility. So as long as it's not exiting your facility, so it gets recycled someplace else. So if recycling takes place within your location and it's also reducing your material input, that also can qualify as P2. And our main goal is, with all the projects that we work on, is to try to tackle benefits that will apply to people, planet, and profit, which is what we call the triple bottom line. And our goal is to make sure we have good preservation of all the important resources that we have in Kansas today, so that future generations can also take advantage of those resources. So we currently have some increasing pressures on water resources, especially for the agriculture and general industry. We have energy costs that are rising, and grids are facing greater demands. So when we're doing P2 and we can increase efficiency, we can also reduce that impact on the local grids. And with this, with all these types of initiatives, we are going to be conserving resources and helping Kansas have an economic, stable system, protecting environmental and public health, and also making sure that local industry is resilient, as well as communities. And we also have been focusing a lot on environmental justice initiatives. So the idea that we want sustainable practices to benefit everyone, regardless of background or income. So our principle is that when we have cleaner operations, we overall have healthier communities, and industry can make choices. So replacing, for example, safer chemicals, improving waste management, enhancing their overall energy efficiency. So that has an impact that is not only within the actual industry location. For example, if you're reducing toxic chemicals, you have some direct benefits to the industry. For example, lower regulatory burden, reduced waste generation, increased efficiency, and you're also improving the workplace for your employees. So you have a healthier workplace. We also, by eliminating some toxic chemicals that are HAPs, or hazardous air pollutants, or volatile organic compounds, for example, we can provide cleaner air for nearby residents, and also protect things, for example, local waterways, by avoiding spills or any sort of accidents that contaminate or impact aquatic systems. So again, just to piece everything together with that whole idea of helping people, profit, and the planet as well. And why are we focusing in these specific industries for this webinar? So this stems from EPA's national emphasis areas. So NEA's 3, 4, and 5 would be automotive, aerospace, and metal manufacturing. And one of the reasons that this was emphasized in P2 initiatives was because of the energy intensive processes that take place within these types of industries. So high energy use in manufacturing and maintenance, which leads to greenhouse gases emissions and high operational costs. We also have the use of toxic chemicals. So for a lot of processes such as cleaning and coating processes, and that can also pose a risk to worker health, community safety, and it's a problem or a concern in terms of compliance. And with overall waste generation, so these industries, they do generate large volumes of hazardous and non-hazardous waste, like scrap materials, spent solvents, and that can also contaminate local water systems. And to show here, this is a tool that EPA has available called a P2 Environmental Justice Facility Mapping Tool. And in this tool, we can actually identify businesses that are part of those 3 NEAs or those 3 national emphasis areas, and also are located in areas that are considered disadvantaged environmentally speaking. So areas that have a significant environmental burden above the average, very much above the average of other areas in the state. So in Kansas, for example, we have over 260 NEA facilities that are located in environmental justice area. So basically our program right now has been trying to prioritize working with these companies. And we do have some extra resources available to facilitate this service. So areas to be covered today, I'm going to be on the pollution prevention side of things, and I will mention some potential initiatives for this area, for this sector, including energy efficiency, water conservation, and hazardous waste reduction.
And I'll be speaking on the compliance side, looking at air quality and waste. And when it comes to air quality, we'll be talking about the National Ambient Air Quality Standards, national emission standards for hazardous air pollutants. And then for waste, we've got the Resource Conservation Recovery Act for hazardous waste. And then at least here in Kansas, because I have more of a Kansas focus, talk a little bit about special waste, which has a different definition than EPA special waste. And something to mention while we're going over those compliance slides is that we are not a regulatory agency. Ultimately, the final word is from your regulator. Other thing to note is that other states might have different definitions, requirements, especially using this term special waste here. And this is, as you can most likely tell, not a full exhaustive list of possible regulations that could impact this sector, but are simply some of the larger compliance concerns that could be.
Yeah, and just one thing I wanted to mention as we go through the different areas of potential P2 projects, I'm going to be referring to some projects that we've done within our program as examples, but we have more than 100 of those case summaries available on our website if you want to dig further into other types of initiatives. We unfortunately don't have time to cover everything, so we picked some examples that we think would be very beneficial for this sector today.
So right out the gate, I do want to give a kind of a broad overview or background on some of these regulations. So as we go through, it's easier to understand the link between P2 activity and the possibility of reducing regulatory burdens. So when it comes to air quality, as I'd mentioned, I'll be discussing a bit about NAAQS and NESHAP. So NAAQS, National Ambient Air Quality Standards, essentially what it does, it tries to protect the quality of our air, right, throughout the entire country. And so it's looking at a list of 6 specific compounds called the criteria air pollutants. So that includes sulfur dioxide, carbon monoxide, particulate matter, nitrogen dioxide, ozone, and lead. And essentially the country is kind of divided down into zones, and each zone is monitored for those criteria air pollutants. And if a zone is outside the threshold, it's considered non-attainment. And if you're underneath the threshold, you're in attainment. You have good, healthy air. So each of those areas is unique, right? The industries within those areas are unique in that the geography can impact the ambient air quality. Weather systems are different across the country. And of course, your industries have different processes. And so as a result, to try and be in compliance with NAAQS, each of the facilities are regulated by permits. And to know if you actually need a permit, you would be looking at something called your potential to emit. So we'll talk about that in the next slide, but essentially, if your potential to emit exceeds a certain threshold, which you can see on the right-hand side of the screen there, then you have certain permitting requirements. If you exceed that level and you happen to be in an area that is in non-attainment for one of those criteria air pollutants, then you will be facing stricter requirements because the goal is to try and get to attainment, trying to reduce the levels of those criteria air pollutants. So on the NESHAPs, this is something where the NESHAPs are concerned about reducing cancer risks, health risks in urban environments. And so EPA was charged with identifying the top, I believe, 30 air toxics that could be contributing to cancer rates in those urban environments. And they later expanded it. And so we've got a list of 188 chemicals called hazardous air pollutants. And so with NESHAPs, you're not necessarily regulated based off of individual permits, but what you are regulated off of is kind of a blanket set of requirements that would be applicable to each of the individual NESHAPs. And there are multiple different kinds of NESHAPs that are based off of if you are a smaller polluting source or a major polluting source, different industries, different processes. And so there are a couple of NESHAPs that I'll talk about in a later slide, but something to note is that there is sometimes a link between NAAQS permitting and NESHAP applicability, specifically at least here in Kansas, where some facilities could require a permit if they are subject to a NESHAP. Next slide. Yeah, so here's a little note about the PTE, potential to emit. Essentially, the idea is calculating how much pollution your facility could emit in a situation where you're operating at maximum capacity, full throttle, every day of the week, every hour of the day, every week out of the year, 24/7, 365. And something to note here is that you cannot account for pollution control devices or practices unless it is something that is already a part of a permit. But you can account for bottlenecks and limitations, operational limitations. That does not include man hours, though. If you have to assume maximum capacity regardless of how many people you've got available to work. So you end up calculating your PTE based off of possibly measurement devices, emission factors. So say you have a boiler that's using natural gas, well, then you can look at an emission factor for that natural gas, for how much sulfur dioxide could be emitted based off of the quantity. And then you just essentially assume, your boiler operates this long, it uses this much gas, using that emission factor, then you know how much potential sulfur dioxide could be emitted through that year. And to help with those calculations, there are a number of calculators that are available for folks to use, covering a broad range of specific processes. But that's kind of a very brief overview. And if you want to look at more details about it, such as some of the actual calculations, then we have a resource available on our website you can look at. As to waste, though, so here in Kansas, we have a term special waste that is very different from EPA's definition, where special waste is essentially any kind of waste that requires special handling. So if you have vast quantities of waste, if the waste is petrissable, I probably butchered that word, but if it's like a biological waste that's going to be breaking down and posing a hazard to the waste system, it would probably be special waste. And special waste requires disposal authorization from the regulating agency here in the state, and so you have to fill out a specific form to actually get that taken care of. But then we also have RCRA hazardous waste. In this case, essentially, it just is that in the past, we had some trash that was incredibly dangerous to human health and the environment, and it needed regulating. So we have RCRA. And within RCRA hazardous waste, there are two broad categories: characteristic waste, which is based off of the characteristic of the material, whether it's ignitable, reactive, toxic, or corrosive. And we have listed waste, which is based off of the actual process that generates the waste. And the overall framework for it is that you do a determination on your wastes to see which wastes are hazardous. From there, you see how much hazardous waste you generate each month. From there, you compare that total quantity to a list of thresholds to determine your generator category. And then you follow the requirements for that generator category. If you do that, you do not need a permit. But if you start engaging in other activities like treatment of hazardous waste, you do require a permit. The larger the category, the greater the burden. And here are those categories right there. The federal versus Kansas with their generation limits and accumulation limits.
Okay, now switching gears a little bit. So starting with energy efficiency projects, that has been something that we've been working with for decades, and we still have a lot of companies that haven't really implemented some of those energy efficiency projects. So as an example, we worked with a lot of companies even this summer working on replacing fluorescent lighting with LEDs. So that not only reduces the energy costs for the facility with energy savings, but also reduce the equipment wear and tear. There are some other benefits that we sometimes don't immediately think of. For example, the fact that fluorescent lighting has likely some mercury in it. And when you switch to LEDs, that would not be the case. We have to make less replacements of those lighting tubes as well, which can also help with worker safety. In a lot of cases, it's really costful to go all the way up and keep replacing those lights on a frequent basis. And we've been pairing up this type of project with occupancy sensors as well to further enhance those energy savings and overall cost savings as well, as those equipments they became much cheaper in the recent years, and the technology got also much better when it comes to bigger warehouses. You can also implement occupancy sensors. And just to tap one more time on that triple bottom line idea. So most of our P2 projects, whenever we look at all the benefits, we can see, again, the three categories of benefits. So for example, with those energy savings projects, with the fluorescent lighting and the occupancy sensors, we have that cost savings. We have really short payback periods right now with lower costs for implementing those new systems and that longer lifespan. We have that planet component with less emissions from electricity, which in a lot of cases is mostly from burning fossil fuels still. We have that reduced waste from the bulbs. And on the people side, we have that component of less hazardous materials. You can also implement a better lighting system, which can become safer for employees to work at that location, and also that lower maintenance hassle. So there's a little bit of a lower risk associated with those replacements too. Looking at other projects under energy efficiency that our program has been constantly working with would be related to motors. A lot of companies have been interested in replacing traditional motors with variable frequency drive that can really reduce your energy consumption depending on the type of system and product that you have in place. So this all needs to be assessed on a case-by-case basis. But overall, a lot of those initiatives have been really, really beneficial for the company, cost-wise and environmentally wise. Compressed air systems, those are pretty much everywhere we go to, and we always find leaks when we are doing some of those compressed air leak audits. Those are big energy hogs for facilities, and overall compressor systems are on average pretty inefficient. So making sure that you implement that preventive maintenance and you're constantly looking for those leaks can be really helpful. We also have been looking at boilers and ovens and how can we, increase operation efficiencies, reduce those costs. And that can be in the form of the sizing, insulation in all this, the actual boiler or ovens and their systems and piping systems. Even sometimes changing the technology. We see a lot of companies trying to get away from gas, from natural gas, and trying to convert to electric. We did have a boiler replacement case this summer in which the company had this pretty large gas boiler system, and that was not that was too big. That was too much for what for their current processing lines. And they found out that they could replace that big boiler with electric heaters. And even when we offset the environmental the GHG emissions from those electric heaters, we still had some very significant environmental savings and also cost savings for that facility. And we're also seeing companies interested in heat recovery projects too. And just to visualize, so we always talk about air leaks, how they can be a big source of waste, environmentally speaking, and cost wise. So based on a small example here, one small leak can cost almost up to $1,000 per year. And depending on the size of the leak, we may be talking about over $3,000 per leak. And we've been to facilities with almost 100 leaks in their system, so they can benefit a lot from, those constant air leak audits and also fixing, of course, those leaks on a regular basis.
So when it comes to compliance benefits for air quality due to energy efficiency projects, it really comes down to the possibility of reducing your PTE. And so when we're looking at energy efficiency projects, the ones that are likely to reduce PTE would be where you're changing your emission sources, such as by downsizing a boiler or an oven, or replacing the equipment with the same capacity, but a more efficient version. Or simply replacing emission sources with electric options that don't even take natural gases or fossil fuel. So with that said, I do want to make a very good quick note there that simply reducing equipment runtimes as a way of improving your energy efficiency does not actually lower PTE, because PTE, right, is the worst case scenario where you're assuming maximum capacity, maximum runtime. So you would have to actually change the equipment to reduce PTE. But if you do manage to reduce your PTE values below one of the permitting thresholds, then that's something that I would recommend you would contact your regulating agency to see if you can reduce or eliminate some of your requirements. Additionally, if you change from a major source to an area source, which the table 3, the bottom table, is actually the threshold for major source. So if your PTE is above that, but then after making adjustments, you go below that, then you'd want to reassess what kind of NESHAPs you are subject to, as NESHAPs are split between major source NESHAPs and area source NESHAPs. Something to note there as well, though, is if you are a major source and you go to an area source, that you'll want to take a look at something called the MM2A rule, the major MACT, or maximum achievable control technology to area source rule, which means that some major source requirements may still apply even if you are an area source. That's only applicable to a small number of NESHAPs from my understanding. But regardless, it is something to know that if you change your PTE values and you change your source designation, then that's going to change your NESHAP applicabilities. When it comes to waste, there's a potential to reduce the amount of hazardous waste that you generate each month. And in this case, that would predominantly be through replacing your hazardous waste lamps with something that's not a hazardous waste, like replacing fluorescent lights with LED lights. The note there, however, is that uh, hazardous waste lamps can be managed as something called universal waste, which does not count towards monthly hazardous waste generation. So if you're unable to make a switch to LED for whatever reason, then you can try and manage your hazardous waste lamps as universal waste to still reduce your monthly generation rate. If you are able to go to LEDs, then at that point, you don't even have to worry about universal waste. So it's still a win-win to go to LEDs. And once again, the benefit there of reducing the actual rate of monthly rate of hazardous waste generation is that you might be able to reduce your category, and by reducing your category, reduce the burden.
And briefly talking about water conservation projects, most of the things we look at right now is regarding reducing the actual usage of water in processes and also potential losses. So repairing leaks, literally going around and looking for any potential water leaks at the facility, shutting off processes when not in use. We did work with a few projects related to implementing sensors to identify when that water was needed and when it was not, so you can shut off. And also, in a lot of cases, conserving water can include conserving energy if we're talking especially about heated water. And of course, there's all the pumping involved in getting that water to the location you want it to be. So a lot of savings can be found in these areas. Low flow systems and aerators is also something we've been working with. It's a simple initiative, normally pretty cheap to implement. And another area that we are seeing, especially in the metal fab industries related to tanks. So anodizing tanks, looking at covers to prevent water from evaporating. And I will briefly talk about one example with some data later on in one of those case summaries.
So when it comes to compliance benefits, when it gets to air quality, at least, one example I could think of had to do with boilers, right? So if you're reducing the total amount of hot water that you have to use at your facility to the point that you can downsize or replace that boiler, then once again, there's a possibility of reducing your PTE values and also altering the applicability of certain niche apps. So for instance, there's if you're an area source, you have a boiler, you might be subject to the JJJJJ niche app. And there are certain boilers that are excluded from that specific niche app. So changing a boiler from one boiler that is subject to a different boiler that's not subject would reduce some of the requirements under that niche app. When it comes to waste, this is once again looking at reducing your generation rates of hazardous or special waste. And the way the connection there to water conservation is through treatment media. So if you have an on-site wastewater treatment system, and your reduction of water is linked to the reduction of chemicals needed, such as in a process tank for electroplating, then you could feasibly reduce the amount of treatment media that you're using each month. And if that media has to be handled as hazardous waste or special waste, then boom, bam, reducing the total amount each month can help with lowering your generator category. Same thing goes for air filtration. So this is specifically for tank covers. So if you do have tank covers, some of the systems that pull air off of the top to reduce worker exposure to certain toxic compounds, you don't have to spend as much on some of the media there. The other benefit there is that it also helps save a lot of energy because you don't have as much air being conditioned through your AC units. So there's a big energy savings to tank covers too.
Okay, and on the last component, and this is probably where I will be spending a little bit more time than the other ones, and it's related to hazardous waste reduction. And we know that this is a very important component in these sectors. So we know a lot of those businesses deal with painting and coating processes. And we have been looking into optimization opportunities related to training of painters and even on how to, how to clean parts, what is the best technique. Equipment upgrades, for example, we start with, do you already have HVLP guns? Maybe we can take the next step and look into electrostatic guns, paint guns, or even powder coating opportunities to reduce that VOC or HAP. Again, chemical replacements too, trying to look for, chemicals that aren't as hazardous. We're looking into advancing inventory control as well. Sometimes, there are those chemicals that have a really short shelf life, some sealants. So looking into advancing inventory control and reducing losses, it's definitely an opportunity, and basic preventive maintenance. So as an example, we did a project with Webco Manufacturing here in Kansas in which they implemented, they were looking at replacing HVLP guns and going with electrostatic spray guns. So this is a painting device that basically uses an electrostatic charge to attract paint particles to a surface. So it increases overall transfer efficiency. And with that project, for example, a reduction of about 180 gallons of liquid paint, with cost savings of almost $7,000 annually, and some extra costs related to the hazardous waste disposal. Of course, we have some emissions reductions in hazardous air pollutants or HAPs and VOCs as well. So we always like to look at the hazardous waste reduction projects from an input and an output perspective, because we understand that it's very costly to manage that hazardous waste after it's generated. So if we can reduce that waste from being generated, there's also some disposal costs that can benefit the project overall. And one thing that we focused, one area that we focused considerably in the past couple of years is related to solvent alternative replacements. K-State did a project in partnership with the Toxics Usage Reduction Institute, TURI, at the University of Massachusetts Lowell. And in the Institute, they have a lot of great resources. I will briefly talk about some of those. And they also have training available on how to find alternative replacements for solvents. We did work with 4 different project participants in this project, and the goal was to come up with a comprehensive assessment for suitable alternatives for their processes, considering sometimes changes in the process material or the technology. So the Cleaner Solutions tool is a database that has a lot of the testing done by the lab and what they found to be a successful replacement and whatnot. So it goes both ways. You have some options to fill out, for example, the solvent that you have and that you would like to replace. There's some optional fields, for example, what is the contaminant that you're trying to clean? What is the material or the part made out of, the substrate? And the equipment that you currently have in place. So you can compare different solvents, and that can give you a head start on what can you replace your current solvent with. Of course, there would be some extra steps regarding, actually testing in your process to see if that would work or not. But again, this gives you a really good head start on what to choose and what should you consider. And on that same side, they also have a tool called P2 Oasis, in which they provide safety evaluations with a scoring system from lower concern to very high concern. So whenever you're looking at a replacement, you can also check the different types of benefits that replacement would give you. So it comes from an environmental health and safety perspective with 8 different categories. And that is connected to that other Cleaner Solutions database. And how do they test? So they check out, so they have a lot of different available equipment to do that cleaning. So what we did with our partners was collecting some samples of what the company considered to be a clean part and what the company considered to be a dirty part. And there was a lot of SOPs for collecting those samples and making sure we understand the process, and we report all of that back to TURI. So there's a fully detailed client form that has to be filled out. And then they go ahead at their facility and they would test out some potential solutions and report back on what did work and what did not work. So results for this project, so we analyzed 4 different processes with different types of sometimes contaminant and sometimes the solvent. So for example, one process was aluminum soiled with grease, and the current cleaning method was a vapor degreaser with TCE or trichloroethylene. Another process was fiberglass soiled with wax, and they were doing also vapor degreasing but using PERC instead. And the recommendation from TURI in that case was switching to unheated ultrasonics and then using different types of solvents. So they gave a variety of actual potential options for the company to choose from. In this case, for example, all the chemicals, they would not be HAPs anymore or hazardous air pollutants. They would still be VOCs. And they also gave out a low or no VOC option with a different type of cleaner, but it only worked for one of the processes. So they definitely gave some opportunities for improvement for the facility. And this is an example of what testing results look like. So, for example, they have that clean part, they contaminate that with whatever the contaminant is, and they have that weight of the dirty part versus the weight after cleaning. So they could compare, the cleaning efficiency. They average out those results to get to a number that is at the quality level that the company is expecting. So for example, when they compare clean and dirty from the original parts sent out by the company, they got that really high cleaning average. So they need to make sure that we're going to be beating that cleaning list level that the company requires. So in this case, for example, for the first process, that first cleaner was identified. It cleaned almost 95% of all the contaminant in the part, which matched their original requirements. And this is a screenshot of that P2 Oasis tool. So for example, that company with those processes, we were talking about PERC and TCE, and those are pretty bad when it comes to all those environmental health and safety categories. And then we can also look at the identified alternatives to see where those benefits would be coming from. So it's just an extra, analysis tool for you to understand better what that replacement will, how it will impact your company and your workers. So other processes that we tested for, one was aluminum soiled with a primer. And the current method of cleaning was a manual wipe with MEK, and also a paint gun soiled with wet paint. And the current method was siphoning MEK through the paint feed line and then through the gun. And in this case, the company was not interested in actually replacing the system. They were looking into a new solvent alternative per se. And the suggested replacement was a combination of 2 solvents that are non-VOC or VOC exempt, used individually or in combination. It depended on the process. So we worked with this project by furthering to the next step, which would be going ahead and having some recommendations for making that chemical replacement. So the new chemicals were slightly more expensive than the current MEK that the company was using. So what we suggested was to combine the new chemicals with a solvent recycling unit. The unit would cost approximately $14,000, but with the recycling component, even with that slightly higher solvent cost, they still got about a 4-year payback period, and they could eliminate about 1,000 gallons of MEK that they had to manage afterwards as well. And also almost 7,000 pounds of volatile organic compounds from that MEK. So we did other types of solvent reduction initiatives. Our institute did a big project with Spirit Aero Systems, looking at a lot of different options on how to reduce that solvent at the facility. So it included optimizing some systems, recycling some of that solvent. So we do have this case study available on our website, so you can check out the complete report. And we also have a video on our YouTube channel with some solvent reduction tips. So they go over some practical examples on how to reduce that solvent usage.
So when it comes to air quality benefits from waste reduction projects, no surprise, there's the possibility of reducing PTE values. Again, in this case, that's through reducing the total quantity of certain chemicals that would need to be purchased each year. So if you have a more efficient system process, if you replace a certain material with something that is not HAP bearing or VOC bearing, then your PTE values could in fact go down. The other thing here, though, is that there's a chance of simplifying NESHAP requirements. So, for instance, a lot of folks in this industry, if they're an area source, are subject to the 6X NESHAP. And so if you are in the target industry, such as metal finishing, metal goods construction, that kind of thing, and you're an area source, then there is, in fact, a requirement that you do some notification and record keeping. But if you are in that target industry and you are an area source and you happen to engage in a certain covered activity, then you have more requirements. So the idea is that some of these waste reduction projects could eliminate the covered activity, reducing the need to have those management and reporting requirements. So for instance, under 6X or 6H, there's spray painting. Spray painting is a covered process. And so if you are spray applying coatings that contain certain hazardous air pollutant metals, such as chromium, then that is then a covered activity, and you are now subject to the additional management and reporting requirements of the 6X or the 6H NESHAP. So that's something to be aware of if you're able to eliminate a HAP containing material or one of those covered processes, then you could significantly reduce the requirements, the compliance requirements for a NESHAP that you might be subject to. In terms of waste, as you might imagine, if you reduce the amount of hazardous waste, then you could reduce your gender category. If you reduce the amount of special waste, then it's simply reduce the amount of burden for applying for disposal authorizations. And if you're able to reduce the amount of special waste to the point that it's no longer considered special, it's no longer needed to have special management requirements, then it could simply be managed as a solid waste, reducing your compliance requirements there. So typical projects, right, as discussed previously, we've got improved management practices, process efficiencies, changing your materials, perhaps doing distillation. But regardless of what kind of project you do, something to be aware of is that if you are changing materials or changing processes such that the hazardability of your waste could change, then you would need to redo a waste determination to reassess if that waste is truly hazardous or not. That process is fairly simple, fairly straightforward, so don't let that hold you back or anything like that from trying to assess new projects. Something else I wanted to put in there is that there are other opportunities outside the scope of P2 that could reduce the burden of managing your waste. And so, for instance, you discussed it previously, but there's a chance of managing your eligible wastes as universal waste, such as those fluorescent tubes, lithium-ion batteries. That's another hazardous waste that could be managed as universal waste. Solvent soaked rags, that's a pretty big one in this industry. And so there's an exclusion. If you follow certain management practices, you won't have to consider certain rags as hazardous waste. Additionally, episodic events, if you have a chemical clean out from doing inventory control, then you can apply for an episodic event to prevent you from going up in a generator category due to that clean out. And of course, scrap metal. If you aren't already recycling scrap metals, go ahead and do so. That is a fantastic way of reducing burn.
Yeah, so to wrap up, I wanted to show just a couple of examples of intern projects for this past summer. And we had Sarah, she worked at 3P Processing this summer, and they were interested in initiatives related to replacing TCE. So they were using a TCE vapor degreaser, and they looked into an aqueous alternative. And also different types of process modification to reduce the amount of solvent for gun cleaning processes and overall solvent use reduction, tank covers. So implementing those and reducing the amount of energy and water utilized. So a lot of different areas, but I just wanted to mention, metal fabricator tackling all those three main areas: hazardous materials reduction, and water and energy conservation. We also worked with Redguard this summer, and they were interested in replacing a wet line with a powder coat paint line. And that can definitely help with some of those hazardous waste generator processes, upgrading their lighting, and also looking into those faucet aerators and other ways of reducing water consumption. And companies have been also reaching out to us interested in implementing solar panels. And that was a project that was also recommended by the company. Some locations and some types of businesses, they qualify for some really interesting funding opportunities. So some companies are definitely taking advantage of that. And if you're interested, you can always reach out to us. So how do I start? We mentioned a lot of these projects were actually intern projects from this summer and other summers in the past. So if you're interested and you're not quite sure if you have anything that qualifies for our program, I'm sure you probably do, but we can definitely offer you a free evaluation to see any potential projects. You can take a look at what are you interested in and what can help you advance your sustainability goals. We are currently accepting applications for host companies that would like to have a PPI intern at their facilities next year. Like I said, we have some cost sharing opportunities available. So if you're interested, like I said, reach out and we can figure out if you qualify for it or not. And we take care of almost the whole process. So we can do the hiring, we train interns, we place them and mentor throughout the whole summer. So they get our full support. And they provide you with a detailed report at the end with a cost analysis of potential alternatives and also an environmental impact of potential projects for you. And then next on the webinar series, our third and last webinar will be focusing on chemical manufacturing. That will take place December 5th at 1 p.m. And the first webinar is available on our website as well. So this one is also being recorded and will be available later. But you can check our website. We have a lot of other videos, including that solvent reduction video in partnership with Spirit Aerosystems. So now we would like to open up for for the Q&A. So any questions from anyone, feel free to ask in the chat or unmute yourself if you would like to. No
Hey,
questions?
thank you all. I'd just like to say thank you all for sharing this information. I actually had come across your organization at the Kansas Department of Labor Safety and Health Conference. I worked 24 years at Procter and Gamble and was trained as an opacity reader and we did stack testing as well and things of that nature. So I am no longer at P&G. I retired from there, but I'm working elsewhere, but I'm in the automotive industry now. And so much of what you had to say today is very applicable to that. So I'm just getting used to your resource that you provide and really appreciate your expertise and willingness to share that and help others in the field.
Yes, thank you. No, we appreciate the feedback, and our website is definitely a good place to start with all the resources we have available, but you can always contact us directly. You can give us a call. We have a hotline as well. But yeah, sometimes, it's easier when you have someone, you can call us and we can brainstorm specifically directed at your company process, your processes, and what exactly do you have in mind. So we definitely do that work of working directly with our clients and finding personalized solutions as well. So appreciate you connecting today.
Thank you.
Thank you. Anyone else has any other questions or comments?
You have us all speechless.
I guess so. Well, if no one has any questions for now, like I said, we have our contact information. I think we have in our first slide, and I could go back all the way to the beginning, but we have our direct contact information. Please feel free to reach out if you have any questions or concerns or comments later on. I want to thank everyone for joining today, and I hope you have a great rest of your day and a happy Thanksgiving.